Okay, we're going to look at normal distribution problems in this video. The problem we have is that English scores on the SAT are normally distributed with a mean of 520 and a standard deviation of 85. The first part of this problem is to figure out what percent of the students who took the SAT had an English score below 500. And as soon as you see the words normally distributed, you should think z-score. And we have a formula to calculate z-score. Z equals x minus mu over sigma. Remember that x is the data point, mu is the mean, and sigma is the standard deviation. So we have all three of those values. We're told the particular value we're interested in this first problem is the score of 500. So that is our x value. We were told the mean score was 520 and that the standard deviation of these scores was 85. So we have negative 20 over 85. Put that in your calculator and change to a decimal. You have negative 0.24. Now what we've just done, when you calculate a z-score, we've calculated how many standard deviations above or below the mean this particular value is. So the value of 500 is 0.24 standard deviations below the mean. The negative sign is the key that it's below. If this were positive, we'd be above the mean. So this is almost 1/4 of a standard deviation below the value of the mean. And we want to know what percent of students who took the SAT had an English score below that value. So we have a standard normal distribution here. So I'm going to draw what's often referred to as the bell curve. Looks something like this, where the mean is always right in the center. So z-score value would be 0 in this case. So you'd have a mean z-score of 0, that's right in the middle, and then since our value is negative 0.24, I know it's to the left of the mean. Now you don't have to be super accurate here. The key thing is that negative values would go below 0, positive values would go above 0, and so this is the value. And on all your normal distribution problems, I want you to draw this and then highlight the area we're looking for. So we want the percent that are below this value, so this is the shaded portion that we're interested in. What percent of the population is that? So if from reading in the text, we know that this entire curve has 100% of the data points below it. There are more data points centered here around the mean, and the numbers of data points get smaller and smaller the further away you go from the mean. So 100% of the data, or 1, if you change that to a decimal, falls beneath this curve. Now what we can do is use the z-score table, which is found on pages 888 and 889 of your textbook, together with this z-score to figure out what fraction of that 1, or what decimal approximation of that 1 is to the left of this z-score. Because the table in your book on that page always tells you area to the left of that z-score. So on your, I don't really have room on here to bring that whole table in, but it consists of really two important pieces. You have numbers down the left-hand column, which represent the ones digit and the tenths place. So I'm looking for negative 0.2 down the left-hand column, and then the hundredths place, which would be 0.04 for the 4, I'm looking for across the top, and I'm going to match that row with that column and see what number I find in the chart there. And so if you match those up, you get 0.4052. And so that is the area beneath this curve to the left of that z-score. Now remember, 100% of the data is under here, or 1 whole. So I have this fraction of 1 here, this decimal value, and so if I want to answer the problem in the form that's asked for, which is a percentage, I just take my 0.4052 and change it to a percentage by moving the decimal place 2 places, so 40.52%, which would be the answer to part A. How many students who took the SAT had an English score below 500? And the answer would be 40.52% of them. Okay, question B also dealt with normally distributed data. It's just that now we're wanting to know what percent of the students scored above 600. So once again, we need a z-score, which is x minus mu over sigma. We plug in our appropriate values. Now we care about the value of 600. The mean is still 520. The standard deviation is still 85. So we have 80 over 85, which if we change to a decimal, we get 0.94. You'll also notice I'm rounding these decimal values to 2 places, and that's because the chart that we've been using only goes out to 2 decimal places as well. So now I'm going to draw my bell curve again. Remember, 0 is right in the middle. This is a positive z-score, so it's somewhere over here to the right. And now I want to shade the portion of the curve that I'm interested in. The question was what percent score above. So above is the same thing as to the right. So I'm wanting to figure out what's that area. Now when I go to the z-score chart, I've got to use the one with positive z-scores, by the way, and I'm looking for 0.9 down the left-hand column, and again 0.04 across the top. So match that column with that row, and we get the value of 0.8264. Now, that's not our answer to this problem. Okay, the z-score table always tells you area to the left, even if you don't care about area to the left. So after we looked at that z-score of 0.94, we find that 0.8264 is to the left. But I really want to know what's to the right. Well, this is where the fact comes in that there is one whole amount of students underneath this particular bell curve. So if 0.8264 to the left and I want to know what's left over to the right, I take my value of 1 and subtract 0.8264, and that gives me 0.1736. And then if I want to put my answer in the form of a percentage, move the decimal place 2 places, 17.36 would be the percentage of students who would score above 600 on the English portion of the SAT. Okay, and so the final part of this question is what percent of the students would score between 500 and 600? Between 500 and 600. Well, we've already done some calculations that we'd need in previous problems. We know that the z-score for the value of 500 was negative 0.24, and we know that the z-score for 600, we just calculated, was 0.94. And let's see if I can draw another bell curve here. So we know 0's there, negative 0.24 is over here, positive 0.94 is over there. Draw some vertical lines up. And this time I care about the area in between. What percent of the students fall between those two scores? Again, if you consult your work from earlier, we know that to the left of negative 0.24 was 0.4052, and we know that to the left of 0.94, we had found from the chart that was 0.8264. So if what I care about is the amount of area in between these two, basically I need the difference between the 0.4052 and the 0.8264. So I'll take 0.8264 and subtract out the 0.4052. And that will give me 0.4212, which, changing it to a percentage, 42 0.12%. And so now you have the three basic type of normal distribution problems. You could either be finding the area to the left of a value, in which case you just read off the chart. You could be finding the area to the right of a z-score, in which case you subtract the value off the chart from 1. Or you could be finding the area between two z-scores, in which case you take the two numbers you find from the chart and subtract them from each other before changing to a percentage. And that's all there is to calculating percentages in normal distributions.